Hello friends, welcome to the video. Our today's topic is integral calculus. This integral calculus is also very important topic while doing the physics course. Will frequently require the knowledge of integral calculus while doing our entire physics course. That's why we'll try to learn integral calculus nicely. Okay, let us start. Let PQ be a curve representing the relation between two quantities x1, x and y. Here, in x and y plane, let PQ be a curve having the relationship between x and y. And let there be the points P and Q. And let's move to next point. The point P corresponds to x is equals to A. Here, the x coordinate of P is A. That means P corresponds to the point x is equals to A, and point Q corresponds to the point x is equals to B. This Q, the x component of or the x coordinate of this Q point is B, or x is equals to B. Now here what we will do is we'll draw a perpendicular line in x axis from the points P and Q. We'll draw perpendicular lines on x axis. Now here we are interested in finding the area of PABQ. That means we are interested in finding the area under the curve from point P to Q with x axis, or simply we are interested in finding the area of PABQ. And let the value of y at x be y is equals to fx. That means the value of different x or different points in x axis, the value of y will be given by y is equals to fx. Now here divide AB into n equal parts. That means here we are interested in dividing AB in n equal parts, and thus if we divide this AB in n equal parts, then the length of each segment will be given as, or divide AB into n equal parts, each of the length del x is equals to AB divided by n, or AB is B minus A. Here AB, the length of AB will be given by B minus A. Therefore del x is equals to B minus A divided by n. Okay, now let's move to the next point. The sum of the area of n rectangular bars. Here I have said it. Here is one rectangular bar. In this way we will get the n rectangular bars, and I have shaded here these n rectangular bars. Now the area of this small or this shaded rectangular bars will be given by area of this rectangular bar plus area of next rectangular bar and area of the next rectangular bar. In this way, if we go on summing the area of each rectangles, then we'll get the sum of total the sum of area of n rectangular bars will be given as del x is equals to fa del x. Here fa del x is this y. This is the area. Fa del x is the area of this first rectangular bar. Fa is the y value, and x is equal del x is base. Here fa is height and del x is base, and therefore this rectangular area will be fa del x. And move to the next rectangular bar. Here the height of the rectangular bar will be given by fa plus del x, and the base is del x. Again, furthermore, if we move to the next rectangular bar, then the height will be fa plus 2 del x, and likewise if we go on adding the areas of these rectangular bars, then we'll come to the final. This rectangular bar area will be f a plus n minus 1 del x into del x. This representation ideas will give the area of or total area of all the rectangular bars under the curve PQ. Or this I dash can be written as I is equal to summation of f a plus I minus 1 into del x, where into del x, where this will give the height of the ordinate or the height of the rectangles, and del x is the base. And if we sum all the rectangular bars from I is equals to 1 to n, then it will give the sum of all the rectangles or the sum of the area of all the rectangular bars here. Here let I dash is equals to summation from I is equals to 1 to n f xi. Here I have denoted Ix as this Ix is equals to a plus I minus 1 into del x. And here I dash is simplified. It's simplified equation. I have tried to simplify this equation as I dash is equals to summation I is equals to 1 from n f xi into del x. This is the height and this is the base. Where xi are here, xi are fa, or xi, the value of xi will be a plus del x. In such a, if we go on moving, the last f xi is, or last value of xi is b minus del x. Here the simple way of understanding is, simply we can understand this I dash will be the sum of areas of all the rectangular bars. But this sum of all the rectangular bars will not be the perfect area of PABQ, because above these rectangular bars there are small triangles, and this area of the triangles are not added. That's why the area will not be exact to the area of the PABQ. That's why the area I dash is slightly different, or it will be lesser from the area of the, it will not be, it is, the area I dash is smaller than the area, perfect area of PABQ, because of the small triangles above each of the rectangular bars. If we increase the number of intervals n, here if we increase the number of intervals n, if we go on increasing the number n, then the vertices of the bar touches the curve PB at many points and total area of the small triangles decreases. That means if we increase the vertical lines, or if we divide this AB in many lines, or if the number of n is increased, then the lines, vertical lines, will cut this curve at many points, and that's why there will be the decrease in this area of the triangles. Now as n tends to infinity, what happens if n tends to infinity? That means here we can see here, if n tends to infinity, then the value of del x tends to 0. That means if n tends to infinity, the vertices of the bar touch the curve at infinite number of the points. This vertical or what I've written here is n tends to infinity, the vertices of the bars touches the curve at infinite number of the points, and the total area of the triangle tends to 0. That means is the number of, or if we divide this AB in infinite numbers, then del x will be 0. That's why the area of these small triangles will tend to 0, and in that case we will get the perfect area or the actual area of PABQ. That means we will get the area of PABQ if we divide this segment AB in infinite intervals. That's why here we can write the perfect, in such case it will give the area of PABQ, perfect area or actual area of PABQ. And if we denote the area of PABQ to I as I, then I is equals to perfect area, this expression will give the area of perfect area or actual area of PABQ if and only if del x tends to limit 0. And that's why the area of PABQ here, the area of PABQ, or which is equal to I, is equals to perfect area of the PABQ if and only if del x tends to limit 0. And here in our mathematics, we will denote this expression or this equation as like this equation. In mathematics, this quantity is denoted as I is equals to fx dx. Here dx is the small element or the infinitesimal change in dx, and fx is the function. And here in mathematics, this quantity is denoted as I is equals to integration. This is the thus in mathematics, this quantity is denoted as I is equals to integral of fx dx from a to b, and is read as integral of fx with respect to x within the limit x is equals to a to x is equals to b. Here a is the lower limit and b is the upper limit. Here this equation is nothing but it just gives the area under the curve, and the curve is related relation between fx and dx or y and x, and it will give the area under that curve from the point x is equals to a to x is equals to b. And here I have noted integration is just area under the curve. Now let's have a look to some of the important integration formulas. Okay, integration of sine x with respect to dx is minus cos x. Integration cos x dx is equals to sine x. Integration sec square x dx is equals to tan x. Integration cosec square x dx is equals to minus cot x. Integration sec x dot tan x dx is equals to sec x. Integration cosec x dot cot x dx is equals to minus cosec x. Integration of x to the power n dx is equals to x to the power n plus 1 divided by n plus 1. Integration of 1 by x dx is equals to ln x. Integration of 1 over x square 1 by x square plus a square dx is equals to 1 by a tan inverse x by a. Integration of 1 divided by root under a square minus x square dx is equals to sine inverse x divided by a. Here we can see there are no upper and lower limits, and if lower and upper limits are not given, then in each case there will be addition of some constant in RHS.